Mathematical modeling and kinematics. Mathematics for A-level students. Mathematical modeling and kinematics part 1. Okay, what is mathematical modeling? Mathematical modeling is described as conversion activity of a real problem in a mathematical form. Modeling involves to formulate the real-life situation or to convert the problems in mathematical explanations to a real or believable situation. Once again, mathematical modeling involves to formulate the real-life situations or to convert the problems in mathematical explanations to a real or believable situation. Means this mathematical modeling will help students how to simplify the problems and how to solve that easily. When a problem is solved using mathematical model, all the assumptions should be stated clearly at the start. So that's why we need mathematical modeling to solve the problems. Mathematical modeling will help us to simplify the problems and how to solve that easily. Okay, students, the first thing that very needed for the mathematical modeling is Newton's law for kinematics. Okay, students, we are going to review first about the Newton's law. There are 3 Newton's law. Now we're going to take a look at the first law. The first law, an object at rest stays at rest, and an object in motion stays in motion with the same speed in the same direction unless acted upon by unbalanced force. The keyword of first law is rest stays or the same speed, motion with the same speed. Commonly, the first law is called by the law of inertia or equilibrium or balance force. For the first law, the velocity is constant, means the acceleration is 0. The velocity is constant or uniform, and the acceleration is 0. Why the acceleration 0? Because the acceleration is change in velocity divided by change in time. Because of the velocity is constant, okay, it will be acceleration equals to 0. Okay, now we go to the second law of Newton's. Second law. The time rate of change of the momentum of a body is equal in both magnitude and direction to the force imposed on it. The time rate of change of the momentum of a body is equal in both magnitude and direction to the force imposed on it. Commonly, forces are unbalanced. Once again, the second law of Newton's, forces are unbalanced. Because of the forces are unbalanced, means will create an acceleration. The motion will create acceleration or deceleration. The second law will be formulated as acceleration equals to sigma of forces divided by mass. Once again, acceleration equals to sigma of forces divided by m. M is a mass. Okay, the third law of Newton. The third law of Newton stated that when two bodies interact, they apply forces to one another that are equal in magnitude and opposite in direction. The third law, called as the law of action and reaction. Okay, look at this sample. When this car is moving to the right, there is driving force acting to the car. But for the opposite force, there will be air resistance acting to the car. So based on the third law, driving force equals to minus air resistance force. Once again, driving force equals to minus air resistance. Very simple, right? Okay, this Newton's law is very helpful to us to take a modeling in mathematics and how to simplify and how to solve that easily. The important thing of the mathematical modeling of kinematics is free body diagrams. Do you remember about free body diagrams? Free body diagrams is to analyze forces diagrams, magnitude and direction acting on a system or object. These free body diagrams to analyze forces diagrams, magnitude and direction acting on a system or object. Okay, look at this object. We are going to do the free body diagram for this object. As we know, all objects will be attracted by the gravity forces. We call that gravity forces, symbolized with W. This gravity will be attracted downward. Okay, the next force is normal force. Normal force or surface force. We'll find normal force or surface force when the object lies on the surface. For the right side, we'll find push or pull force. And then we'll find the opposite one to the left side. We call that friction force. Friction force will be exist when the surface is non-smooth. But if the surface is smooth, there is no friction force. We call this one free body diagrams, right? Okay, students, I want to help you how to understand free body diagrams, how to draw the free body diagrams on a case. Okay, look at this one sample. Example 1, draw the free body diagram of this object. How to draw the free body diagram for this object? Okay, look at this diagram. The direction is the right side. And there is one force covered by angle alpha. Students, the surface is smooth surface. Once again, I want to emphasize at least there are 5 forces to be identified for one object. Number 1 is weight force or gravity force. The gravity force is compulsory to all objects. And then we can identify it for the rest, normal force, pull or push force, friction force, and the tension force. Let's start. Draw the free body diagram on this object. Okay, 5 forces to be identified for an object. Number 1, weight force or gravity force. All object has the gravity force because the object will be attracted to downward based on the gravity to the center of Earth. We call this one W. The opposite one is normal force. Normal force is axis. Why? Because this object lies on the smooth surface. We call that N as a normal force. Okay, the third one is F, pull or push force. Yes, there is pull or push force. The symbol is F. But this F covered by alpha as an angle. Because F does not lie parallel to the x-axis, we have to do the projection. The projection will create two another forces. I mean, there are 2 forces will be created to the x-axis and to the y-axis. To the x-axis, we call it Fx because Fx parallel to x-axis. And the rest is Fy because Fy lies on the y-axis. By using the trigonometry, Fx is F cosine alpha and Fy equals to F sine alpha. That's very simple, students, because we can construct the triangle, yeah, covered by F, Fx, and Fy, and then we can use sine alpha and cosine alpha as the simple trigonometry, right? Okay, based on the Newton's law, the first law is sigma Fy equals to 0 based on y-axis. Why sigma Fy equals to 0? Because this object is moving to the x-axis, not y-axis. So that's why sigma Fy equals to 0. Based on the based on the y-axis, we'll find that y is downward and Fy is upward. So we can write that y is positive and N force and Fy force is negative because we follow the attraction of the gravity is downward is positive. So we can write that W minus N minus Fy equals to 0. Very simple, right? Next, the second law. Sigma Fx equals to m times a for the x-axis. As we know that the direction is to the right side. Okay? So the acceleration follow the direction. So that's why sigma Fx equals to m times a. And as we know the direction to the x-axis, we can write here that Fx equals to m times a. Look at the diagram. For the x-axis, there is one force lies on the x-axis, Fx, but there is no opposite of Fx. So only single Fx lies on the x-axis. So that's why Fx equals to m times a. Okay, now we go to the example 2. Draw the free body diagram. Look at this one. Non-smooth surface. Okay, we can identify the 5 forces for one object. The first one is W, or gravity forces. Yeah, the gravity forces will be attracted to the center of Earth, so means downward. The opposite one to the upward, we call that normal force, because this object lies on the smooth, non-smooth surface. We call that normal. Okay, the second one is force. We can identify for this object there is one force, but the symbol is P2. And P2 does not lie on the x-axis. So we have to do the projection. The projection P2 will create P2x and P2y. Is it right, everyone? And then the last force is about friction. Why we have friction force on this object? Because we already identified this object lies on the root surface or non-smooth surface. Okay, so there is frictions lies to the opposite of the motion. Okay, students, based on the Newton's law, we'll find any forces acting on the free body diagram, right? Okay, the first law of the Newton's, sigma of y equals to 0. Please focus your eyes for all forces lie on the y-axis. There are W force, downward, P1, downward, and the opposite one is normal force, upward, and P2y, upward. If we choose downward is a positive because lie on the y-axis means attracted to the gravity, we can notate that W is positive, P1 is positive, N is negative, and P2y is negative. So we can write that W plus P1 minus N minus P2y equals to 0. Okay, look at the box. Since P2y doesn't lie on the x-axis or y-axis, but covered by angle alpha, we have to do the projection. The projection will create two results, P2x and P2y. Please use your simple trigonometry. Cosine alpha equals to P2x over P2. And sine alpha equals to P2y over P2. Since cosine alpha equals to P2x over P2, we'll find that P2x equals to P2 cosine alpha. And since P2y equals to P2 sine alpha, we can write that W plus P1 minus N minus P2 sine alpha equals to 0. Very simple, right? Okay, what about the second law of Newton? Second law of Newton. Look at the free body diagram. This object is moving to the right side, so means to the right side is positive and negative to the opposite one. Sigma of x equals to m times a. The motions to the x-axis, so we'll find acceleration for this case. For the x-axis, we'll find P2x and frictions to the opposite one, right? Because P2x to the right side and F to the opposite one, we can write that P2x minus F equals to M times A. Since P2x equals to P2 cosine alpha, we can substitute P2x by P2 cosine alpha. We can state that P2 cosine alpha minus F equals to M times A. So once again, students, at least there are 5 forces to be identified to do the free body diagram. Number 1, weight force. That's a compulsory. Number 2, normal force or N. Number 3, F, pull or push force. Number 4, friction force, small f. And the last is the tension force or T. Okay, students, thank you for your attention and goodbye.